Hello and welcome. Let us solve some problems on 1 by square root of a square plus bx plus c form of quadratic equations. So whenever you are solving square root of quadratic equation functions, it is always advisable to find whether the roots exist or not. So the equation is x square plus 5x plus 6. How do you check whether the roots exist or not? We'll find the discriminant. Discriminant is b square minus 4ac. If discriminant is greater than or equal to 0, then roots exist. If b square minus 4ac is negative, roots does not exist. B square is 5 square minus 4 into a is 1, c is 6. So this is 25 minus 24, which is 1. So discriminant is greater than or equal to 0. Therefore roots exist. So if root exists, what are the roots? X square plus 5x plus 6, I can write it as x plus 2 into x plus 3. So the roots are minus 2 and minus 3. So I'll write f of x is equal to 1 by square root of x plus 2 and x plus 3. So what is the domain of this function? Let me bring the number line. The roots are minus 2 and minus 3. So minus 3 comes over here, minus 2 comes over here. If you take anything less than minus 3, take minus 4. What happens here is minus 4 plus 2 and minus 4 plus 3, so which is minus 2 minus 1. Both are negative. Both x plus 2 and x plus 3 are negative because minus 4 is much lesser than 2 and much lesser than 3. So both are negative. If both are negative, the product is positive. So the product over here is positive. Similarly, if you take anything between minus 3 and minus 2.5, let's take minus 2. Anything between minus 3 and minus 2, I'll take minus 2.5, minus 2.5 plus 2, minus 2.5 plus 3. So this is minus 0.5 and this is plus 0.5. One of them is negative, the other one is positive. So which gives negative result? So we cannot have negative square root number. So this, in this area, this region between minus 3 and minus 2, it is negative. What happens if you take greater than minus 2? Greater than minus 2, let us put minus 1. So minus 1 plus 2, minus 1 plus 3, 1 and 3 both are positive. If both are positive, product is also positive. So here it is positive. So the domain is wherever the product is positive. So here it's positive, it is positive. The next question is, very important question is, should we include minus 3 and minus 2? We cannot include minus 3 and minus 2 like we did if we have quadratic polynomial in the numerator. What happens if we include minus 3? If I include minus 3, you will get 1 by square root of 0, which is an undefined function. Similarly, if you put x is equal to minus 2, the denominator becomes 0, which is also undefined. So we cannot include minus 2 and minus 3. So now the domain of this function is minus infinity to minus 3, where 3 is not included, union minus 2 to infinity. Minus infinity is also not included. This is my domain. What is the range of this? How does the curve look? If I have square root of x square plus 5x plus 3, then the curve will be like this. If I have 1 by square root, so now the curve will be like this. At minus 3 it is infinity. From infinity it goes to 0. At minus 2 also it is infinity. From infinity it goes to 0. So the range is for this function, it is 0 to infinity, but 0 we cannot include. Let us solve another problem. So here x square plus 5x, clearly the root exists. you need not to check with the discriminant. If you want, you can also check. F of x is equal to 1 by square root of x times x plus 5. So the roots are x is equal to 0 and x is equal to minus 5. The domain is the domain is we have at 0, and let us take at 0 over here, minus 5 over here. The domain is between, the domain is this area, and we cannot include minus 5, cannot include 0, and after 0. This is my domain. How does the curve look? The curve is, when you put x is equal to minus 5, this will be infinity. Since it is a reciprocal function, it goes to 0 when you increase x to infinity. So this looks like this. From this I can write domain as minus infinity comma minus 5. 5 is not included. Union 0 is also not included. Infinity 0 is not 0 also, 0 is also not included. For the range is, it appears to touch 0 at a very large value of x, and it appears to touch infinity at the roots. So this is domain and range. Next problem, x square plus 9. Let us find, does the root exist or not. A is 1, b is 0, c is 9. B square, discriminant, b square minus 4ac, b square is 0, a is 1, c is 9, this is minus 36, d is less than or equal to 0, d is negative, so no real root exists. No real root exists. What does it mean? If no real root exists, then the function does not touch x-axis only. So here you can put, for domain, you can put any value in the real number set, and that will not make f of x undefined function. The domain is complete real number. So how does the curve look? The curve look like this. It does not touch x-axis. And what is this point? This point is my f max. Why the curve look like this? The curve looks like this because limit extends to infinity. 1 by square root of x square plus 9 does tend to 0. Right? It has to go to 0 because 1 by x square is always a decreasing function. Or if you put 1 by square root also, it's a decreasing function. So let us find the maximum value. So the range, what I say is, the range is 1 by, or I can say the range is f max to 0. What is this f max? F max is actually 1 by square root of minus b square by 4a plus c. So here, since b is 0, this term is 0, so I'll get 1 by square root of c, which is 1 by square root of 9 is 1 over 3. So the range I claim is 1 by 3 comma 0, which is 0.3333 comma 0. So let us verify this on a graph plotter. 1 by square root of 1 over, let's cancel this as well, 1 over square root of x square plus 9. So this is the maximum point, which is 0.33 and goes to 0. Let us have one more problem. So here the root exists. F of x, I can exploit one of the functions, which is x plus 3 into x minus 3, a plus into a minus b is a square minus b square. This what I've done here is 9 I've written as 3 square. So this is actually the domain. I'll directly write the domain. The domain is, the roots are minus 3 and plus 3. So minus infinity to minus 3 not included, 3 not included, infinity. What is the range? The range is, the range of this function is, see, the curve look like this. We have minus 3 plus 3, but minus 3 it has a maximum value to infinity, plus 3 also at maximum infinity. It goes like this. The range is 0 to infinity. Now this is an interesting problem. We have a minus 1, b plus 5, c 0. Let us find whether we have roots or not. Discriminant is b square minus 4ac. B square is 5 square minus 4 into minus 1 into 6, which is 25. 25 plus 24, which is 49. So the root exists because it is greater than or equal to 0. Roots exist. If root exists, what are the roots? The roots are minus x square plus 5x plus 6 minus x square plus 6x minus x plus 6 minus x of at common, we'll get x minus 6 minus 1 of x minus 6. So we'll get minus x minus 1 times x minus 6. Take minus common, you'll get x plus 1 and x minus 6. So the roots are minus 1 and plus 6. So this I can write as 1 by square root of minus x plus 1 x minus 6. So what is the domain and range? We have minus 1 plus 6. So at minus 1, if you put minus 1, this becomes infinity. So it comes down, and at 6 is also it goes to infinity. This is how the function looks like. We need to find this point, which is f minimum. So remember, if I have square root of minus x square plus 5x plus 6, then this curve would have looked like this. Would have looked like this with minus 1 to 6. Here, since it is in the reciprocal, we cannot take minus 1 and minus 6. These two are excluded. So domain is minus 1 to 6, but minus 1 and 6 are not included. How to find the range? Range is f minimum to infinity. F minimum to, because from here it goes all the way to the infinity. And f minimum is included. How to find f minimum? F minimum, before finding f minimum, let me find only minus b square by 4a plus c. Minus b square by 4a plus c is actually minus b is b is b is 5, a is minus 1, a is 5, a is minus 1, and c is 6, which is minus 25 by minus 4 plus 6. So this is 25 plus 24 divided by 4, which is 49 by 4. But f max is 1 by square root of 49 by 4, because the function is 1 by square root of x square plus bx plus c. So this is 1 by 7 by 2 comma infinity, which is 2 by 7 comma infinity. This is included. 2 by 7 is actually 0.26, 0.28 infinity. Let us check on the graph plot. The function is minus x square plus 5x plus 6. So this point is 0.28. That's what we got as well. Next problem. So here this is easy. F of x is equal to square root of, I'll take minus x out, x plus 5, root exists, roots are at x is equal to 0 and x is equal to minus 5. So the domain or the curve minus 5 and 0, curve will be looking like this, because we have square root of minus x square plus 5x. I would write only the domain here. The domain is minus 5 to 0, and I would encourage you to find the range. Range is f minimum to infinity. So what is f minimum? I would encourage you to do this. Next problem is this. So I can write this as 1 by square root of 9 minus x square, which is 1 by square root of 3 square minus x square, and write 3 plus x and 3 minus x under square root. So x is equal to 3 and x is equal to minus 3 are the roots. The domain is minus 3 comma 3, and I would encourage you to find the range of this function. Thank you.